Okay, so today's lesson is from Monday, October 17th, 2011. Today we're going to be going over a PowerPoint on Newton's second law where you'll get some practice solving some word problems. And we're going to follow that up by doing some independent practice where you'll work on your own. And if you're unable to finish, then you're going to go ahead and take that home for homework. Over here again, these are the links that you could click on to get these assignments. Remember that as you walk in, I'll expect you to be following along with the handout that you were given. If you have any questions, again, raise your hand. I'll come over and help you out as we work through this. So let's go ahead and start with this PowerPoint on Newton's second law. Again, we're going to solve some word problems with this law, but before we start that, we need to make sure you understand what the equation is all about. So Newton's second law of motion is an equation that explains the relationship between force, mass, and acceleration. You need to know that there's a linear relationship between force and mass, and also between force and acceleration, which just basically means that if one is rising, the other one is rising. So if the acceleration of an object goes up, or it gets higher, then the force should also move up with that acceleration. This is the equation over here, F equals ma, and F stands for force, and we have a unit there of newtons. Remember we discussed that on Friday. You have m over here is mass, and that's in kilograms. And then a is acceleration, and that is in meters per second squared. Okay. These are the units that we have to be in to get force in newtons. So if our mass or our acceleration are in any other types of units, they need to be changed so that they're in kilograms for mass and meters per second squared for acceleration. We can rearrange this equation to solve for either mass or acceleration. And those two equations, if you were to do the algebra here with F equals ma, to get acceleration, we would just say that the acceleration is equal to the force divided by the mass. And if we wanted to calculate the mass, we just get the acceleration to the other side. It would be mass is equal to the force divided by the acceleration. So these two equations can be derived from this original equation if you go through the algebra for that, and I can help those of you out who don't understand how we got those individually. Okay, so those three equations are going to be the equations we kind of go with as we try to solve these problems. So it's going to be important that if you have any questions at all, that you go ahead and voice those. So this first problem is going to be to calculate the positive net force. Or it's an example of calculating positive net force. So it says two friends are playing tug of war. Michael is pulling to the right with a force of 20 newtons. So this is the force of Michael. And Freddie is pulling to the left with a force of 17 newtons. So that's the force of Freddie. And they want the net force. So the givens here are going to be that the force of Michael, and Michael is pulling to the right. You remember we discussed that anything that's going to the right should be considered positive. So the force of Michael is a positive 20 newtons. The force of Freddie is going to be negative 17 newtons because it's going to the left. The unknown here is going to be the net force. The equation that we'll use to solve this is going to be F net is equal to the two forces added together, and we discussed that last week. So it would be the force of Michael plus the force of Freddie. We would go ahead and substitute these two values in for the values here in the equation. So it would be F net is equal to positive 20 newtons plus negative 17 newtons. When you solve that, positive 20 plus negative 17 ends up giving you a net force of positive 3 newtons. Okay, so this is how we would solve a problem where you'd end up with a positive net force, given two different forces acting in one dimension. Okay, so the next one that we're going to go over is for an object that is actually going through negative net force, and for that one, let's go ahead and go over here. It says a ball is dropping with a force from gravity of 10 newtons. We'll go ahead and identify that 10 newtons. If there is an upward force from air resistance on the ball of 1 newton, then what is the net force? So in this example, they're going up and down the forces, and you got to remember that here up is positive and down was negative. We discussed that last week also, so we'll go ahead and put the givens in here. So the force of gravity would be maybe Fg. Since it's going down, it's going to be negative, so negative 10 newtons. The force of air resistance, we'll just put Fa, is equal to a positive 1 newton. The unknown here is the net force. The equation is going to be net force is equal to the force of gravity plus the force of air resistance. We're going to go ahead and substitute these two values into our equation, and we'll end up with the net force is equal to negative 10 newtons plus a positive 1 newton. Negative 10 plus a positive 1 gives you a solution of negative 9 newtons. Okay, so in this example, you can see we went ahead and got a negative net force given forces acting in the y direction. Sorry. Okay, so the next equation, or the next problem, says finding force given mass and acceleration. So this says a rabid dog named Cujo leaps headfirst into the side of a car with an acceleration of 5 meters per second squared. If Cujo has a mass of 256 kilograms, then what force does he have when he hits the door? Okay, so for this problem, go over here to the given step. We can kind of assume the direction of Cujo is to the right just to make things easier for us. It doesn't say whether he's going left or right, so we can assume he's going to the right for purposes of our accelerations and that sort of thing. So over here we'll go ahead and write in the acceleration is 5 meters per second squared, and we'll go ahead and write in that his mass is 256 kilograms. And the unknown here is going to be his force, the force of Cujo. The equation for calculating Cujo's force is going to be F Cujo equals the mass of Cujo times his acceleration. So this is going to be a really easy problem. We're just going to go ahead and substitute these values into our equation. So the force of Cujo is equal to 5 meters per second squared times 256 kilograms. For these problems, I'm going to want you to go ahead and use your calculator to practice solving these. We always have people who mess up using their calculator, so we're going to take some time to do that with these problems. So I'd like you to go ahead and get your calculator and input this and give me the answer for the force of Cujo. Okay, so the next problem here is going to be to find the mass if you're given a force and an acceleration. So in this problem it says a sly fox uses a lever to pry up a dead tree. If he applied 450 newtons of force to the base of the tree to accelerate that tree 0.6 meters per second squared, then how massive was that tree? Okay, so the givens here, we've got the force that the sly fox put onto the tree, so the force of the fox is equal to 450 newtons. The acceleration of the tree is going to be 0.6 meters per second squared. And the tree is moving up, we would assume, because he's uprooting it from the base. The unknown here is going to be the mass of the tree. So we're going to go ahead and use the equation. I already explained that the equation is F equals ma, but that can be rearranged to solve for mass, where it would be mass is equal to the force divided by the acceleration. So we're going to go ahead and substitute these values into this equation that solves for mass. So it would be mass is equal to the 450 newtons being put onto the tree divided by the acceleration of 0.6 meters per second squared. So that'll give us a solution for the mass of this tree, and again remember it is going to be in kilograms. So go ahead and do this in your calculator. 450 newtons divided by the 0.6 meters per second squared. Okay, so moving on to the second one, finding acceleration given a force and a mass. It says a robot collides into a chicken with a force of 25 newtons, and you know the robot has a mass of 450 kilograms. What acceleration did the robot achieve to create this force? So the givens here are going to be the force that the robot hits the chicken with, which is the force of robot is equal to 25 newtons, and the mass of this robot is 450 kilograms. Okay, so they want to know what acceleration the robot had to create this force. So the unknown here would be the acceleration. The equation for acceleration, remember we start off with that first equation, F equals ma, and then we can rearrange it to solve for acceleration, which is a equals F over m. We'll substitute these two values in where they belong in the equation, and it'll be acceleration is equal to 25 newtons divided by 450 kilograms. And our solution will be the 25 newtons divided by the 450 kilograms. And since it's an acceleration, it's going to be meters per second squared. So go ahead and do that on your calculator and finish that for me. Okay, great. So that concludes our PowerPoint notes. What y'all will be working on now is this independent practice. You'll notice at the top I gave a re-explanation of the guess method to make sure that you understand. Again, you don't have to show, I had this on here, but you don't have to show all your work one problem per page. I think that's a little ridiculous. But you know, try to use your space wisely. So you're going to finish these 6 problems. And again, I've shown you the answers, so there's no excuse for not going through the work. If you have issues with understanding how they got these numbers, please by all means email me and let me know, and I'll help you get to what I'll help you get the information you need to actually get through and solve these problems. That concludes our lesson for today. I appreciate you following along as we went through. Thank you.